Okay, the Module 6 lab activity is not unlike the Module 6 skills test. In the skills test, you did the specific heat of a solid. This time you're going to get the specific heat of a liquid, but you're going to use a very similar simulation. You're going to do many of the same steps. So here's how you begin. Again, you don't need to collect these materials. We're going to do this lab virtually, but notice that it will involve a triple beam balance again, a couple of cups of water, a couple of temperature probes. And the first step is and this is essentially questions 1 and 2 on the lab quiz, is you're going to take a screenshot of the mass of your empty cup. You're going to take a screenshot of this close-in view, and you're also going to read it and enter the numerical value. No need to enter units, just enter the numerical value to the nearest tenth of a gram. That essentially that's questions 1 and 2. Then you put some mystery fluid in your cup. And again, take a screenshot of this close-up view, upload it to your instructor, and get the mass of the cup with the mystery fluid. Enter that value. Then, essentially what you'll be doing is you're going to take the temperature of your mystery fluid, and you're also going to have a cup that's going to have hot water in it. And you're going to get the temperature of that fluid as well in 2 separate temperature probes. And so you wind up with this graph here. The red brownish line, that's actually the temperature probe that's in your hot water. And allow it to come to essentially equilibrium. Let it get horizontal before you do anything. Obviously, the temperature probe in the mystery fluid is this blue line, and notice it's not changing. Once they are essentially horizontal, you mix them. When we mix the liquids together and put the temperature probes in the same cup, notice what happens. The one that was reading the temperature of the hot water cools down. The one that was reading the temperature of the mystery fluid warms up until eventually they both reach the same temperature. So the water seems to have lost heat. The mystery fluid seems to have gained heat. And so you let them come to an equilibrium, and then you're ready to move on to the next step. The next step is to take the mass of the entire mixture together. So now you've got a cup with mystery fluid and water in it. Get the total mass. Now one thing I'll point out is that the long shot of the triple beam balance here is different than the close shot. That's a glitch in the simulation. I've notified the maker of the simulation, and it may be changed by the time you actually are doing this, so you may ignore this part of the video if that's the case. But in any case, take a screenshot of your close-up view and read the close-up view to get the mass of everything together. Of course, now you've taken mass readings of the empty cup, you've taken a mass reading of the cup with the mystery fluid, and you've taken a mass reading with the cup, the mystery fluid, and the water. So with those mass readings, you should be able to figure out what the mass of the mystery fluid is and what the mass of the water are by themselves. And then finally, the questions 10 and 11 are really just doing some math. If you want to check yourself, in question 11 you actually find the specific heat of the liquid. If you want to check your answer to question 11 by entering it in the simulation here, one thing you'll need to do is there's a difference in units. Notice the units here are joules per kilogram per degree Celsius. The specific heat that you calculated was joules per gram per degree Celsius. So you'll need to multiply your answer to question 11 by 1,000 before entering it in the simulation if you want to check your answer. You don't have to check your answer. You don't have to email it to anybody. But we want to make sure that you did this all properly. The important thing is if you're going to check your answer, make sure you multiply your answer by 1,000 before you enter it into the simulation. And that's it. Good luck.